Okay, the garbage exercise number 2. We're going to do something that's little bit more complex than the ergolite conventional decision. We're going to take things into account for the discount rate at which the city can borrow money, and then what the inflation is expected to be over the next 4 years. And in this case, we're going to use two different discount rates, 7, 6, and 7% for these three problems. You'll see there's three sets. They're done exactly the same way, just using different discount rates and inflation combinations. That's what these will be. This is your second problem, third problem. These numbers are constant throughout the problems here. So what we want to do is use these in cell references so that, like if you set this up for yourself to be able to plug things in, these would, like in here, these cells are locked. But like in your spreadsheet, if you had designed this for yourself, then you would just be able to plug these numbers in, and then everything would automatically recalculate down here. So it would save you a lot of hassle. All right. So here, I get a lot of problems with people that make a mistake here. First, the purchase price where it says time is 0. That's like you bought it right now. A year hasn't passed. So in real dollars, it's costing you $400,000. Now, the trick is this is money going out of the system. So to make the math work here, we've got to put this as a negative $400,000. And you're going to do this for both of these first columns of the line because it's year 0. Nothing's happened. There's been no time for either the discount rate to affect anything or inflation would affect anything. So first line is simply negative 400,000, and that will be true for all of these because, again, year 0, nothing's happened yet except you're proposing spending 400,000. So now we want to calculate these benefits. So here's what we're looking at. In year 1, we're expecting to receive a benefit of $90,000. This is what we're figuring that's going to cost in labor. It's going to save us in labor costs, probably by estimating that it's going to cost you, I don't know, say 2 fewer people a year, because your garbage truck's going to be able to move more stuff at a time. You have to put fewer trucks on the road, so it'll save you the driver and like a guy riding the back, and they make $45,000 a year. So you're estimating it's going to save you $90,000. Okay, so we want to know when we do these benefits in a year what we're going to end up with at the bottom of the day. Is this offer to buy this truck with these savings, with this residual value that we're going to get when we sell them or trade them in, under these circumstances, this discount rate and this inflation rate, and then later this one and this one and this one and this one, under these circumstances, is this worth doing? Okay? So this is our dilemma. All we have to do is find out what our nominal dollar costs are for that benefit each year. Remember, inflation is going to go up at, in this case, or in this rate, 7% each year. So 7% this year, then 7% that year, and that year. Okay? So here's what we do. There's multiple ways of doing this calculation. I've seen students that are, kind of math whizzes, or, I had somebody say, well, how do I do this? There's more than one way to skin a cat here. This is the way I like to do it. To me, it just sort of makes sense. So if you feel a different way of doing it, and by telling you the negative 400,000 solves your problem, more power to you. I don't care as long as the answer is right. It mathematically makes no difference. So here we go. I'm going to start out with, this is going to be an equation, and we want to do cell references rather than plugging the numbers in because, again, if you went to the trouble of making up the spreadsheet, you might want to reuse it. So set up in such a way that all you have to do is put in your numbers up here, which you would link like up here in real world. You actually have this as a cell reference. it would just automatically stick that in. So that way you can reuse your sheet. You don't have to do everything from scratch every bloody time. Get it right one time, reuse the spreadsheet. That's sort of the decision-making power of using a spreadsheet, which is sort of where we're going here. All right, what we want to do, we've got our equal sign up, so we've indicated Excel that we want Excel to calculate something. So now we want to tell it what we want to calculate. All right, here, to figure out our nominal dollar cost benefit on this amount, our first year benefit, we're going to want to tell it that we want it that year's benefit. So that's going to be C18. Now, we want to multiply this. That's the asterisk, one above the 8. We want to multiply this by the inflation rate. Okay, so our inflation rate is 3%, but 3% of this number is just going to give us that. It's not going to add anything. So we want this, what we actually want to know here, the way we're calculating this, is we want it to calculate 103% of this. So the way we'll do this is we're going to add a 1 to it. So effectively, in this case, the F8, close the parentheses. So what this tells the spreadsheet is I want you to calculate this number, our projected labor savings in year 1, by the interest rate, or the inflation rate, which is going to tell me in the long run what this $90,000 savings looks like next year when inflation's taken into account. So here we also want to multiply this by the number of years in which inflation is going to be acting on that number. Right? Year 1. So the easiest way to do this, in my opinion, is to raise it to a power. And if you remember your math, when you raise something to a power, whatever the power is the number of times you multiply it times itself. So in this case, it's year 1. Let's just reference the time. You've already got it worked out here. So we'll just do it like this. Close the parentheses. So next year, because of the effect of inflation, this savings, today's savings of $90,000, what we've calculated, as of right now, next year at this time, on a 3% inflation, we would be calculating that as $92,700. Okay? Now understand that we're really talking ballpark figures because we don't know exactly what's going to be. We're just projecting this. And it's a little ballpark figure, but it's the only way we can be matching apples to apples. So we're effectively kind of making educated guesses here. And so if word comes out that, man, we expect a spike in inflation, Fed's going to raise the interest rate a big amount because, we're out of the recession. And so this number, the Federal Reserve Bank is estimating that inflation rate is going to be 3.5% next year. Well, then you might change this guesstimate from 3 to 3.5. Or if it goes down, you revise it down. But by doing a cell reference here, you can get a more accurate number, and you only have to change data that you have. This is your best guess, or anybody's best guess, to get this number. Okay. Now, this is what that is in next year's dollars. Now, to get the present value, we want to know what that is in present dollars, but we've got a little issue here. Here we have the city can borrow money. City can borrow money, the discount rate at 7%. So we want to know what that looks like in present dollars under that circumstance. This number, all right? This number came from this one. This number is coming from this one. So here, again, we're going to tell Excel that we want it to calculate something. So we're going to open a parentheses to give it the arguments. Now, what we want to do is we want to know what this number is in cell D18, right? So we fill that in, give it a comma there to say that, all right, next argument. Now, oh, that was actually back up one here. Actually, it's not quite the way I want to do it. I want to divide that number by this discount, by this discount rate. All right. But again, this would be 7% of number. So I actually want this to be at 107%. So open a parentheses, 1 plus that number. All right. Now we're going to want to raise it to the power of however many years we are, in which case, get our caret. Caret is above the 6. And then since that we're talking this year, be B18. All right. Now, so in present value, this number, next year, we estimate that number is that's what our savings will be worth in next year's dollars. But bringing it back to today's dollars under this amount that we can borrow the money, this is what the present value actually is on that savings, next year's savings. Now, I know this isn't the most intuitive thing you've ever done, so just bear with me and trust me, this works. All right, now, it's going to be we're going to do the same thing here. I'm just going to take these all the way down. I'll do these all the way down, and then I'll show you how we do the calculation here. All right. Told we want to do an equation. Open the bracket. This is the next amount. Again, it's the same amount we were projecting every year. We want to multiply that by 1 plus the inflation rate for this year. All right. Then we're going to raise that to the power of 2 because we're talking about the second year. All right. Same thing here. We want that number. And you see, by doing it like this, if you estimate that the savings is going to be different years, because say if you're planning on phasing out older trucks and buying more of these, you might say that this doubles, $180,000 in year 2. The next year you're going to phase out another truck, and it would be what, $270,000 and so on. All right. So multiply that by 1 plus your inflation rate raised. Come on, give me the right. Raised to the number of years, and here we're talking about being in year 3. Equation, open our arguments, same amount, multiplied by the inflation rate, and to make the math work right, we're going to raise it to 1 plus. And again, there's more than one way to do this, so just if something else makes more sense to you, more power to you. Do it that way. For me, it works this way. I'm good with it, so there we are. All right, now we have another issue that we have to deal with. Now, it's usually most students generally can get this. Where they generally have problems is here. They either try to discount these, or they forget the negative sign, or on the other end of the margin, this happens. We've got to account for the residual value. Sometimes they just say, well, we're going to sell it for $100,000, so I'll just put $100,000 in here. Well, remember, this is 4 years down the road, and what does that $100,000 look like in today's dollars? To get everything to work out right, we need to actually address that. Therefore, equals, open our arguments. We want to do the nominal dollar cost for that residual value of 100,000, which we got from up here, that are leftover expenses. Then we're going to multiply that times 1 plus our interest rate, close the brackets, and then we're going to raise it to that power of the fourth year. That should be right. Wait a minute. All right, what's wrong with this here? How did the math not come up right? Give me a second here. You got to figure out why this is coming up 0, because that should not come up 0. F9. Nearest here. All right. Plus, all right, C22, which is this, times 1 plus F8, raise the power 22, which is the number of years. U should not come up 0. Okay, let's try this again. It's not making any sense here. All right, let me do this one again, because this should come up to about a little over 112,000. I'm being thwarted here. Times 1 plus F8, so brackets, raise the power of C22. Oh, whoops. There we go. I don't know why it didn't look like it. That's the same. It's the same formula I put in. All right. Anyway, there we go. That is the correct formula. Equals C22. This amount, multiplied by the 3% inflation rate, 103% of this amount, and then multiplied by itself, because it's this amount dealt with, it's the residual over 4 years, and so we're going to raise that to the power of 4, or calculate over 4 years. Says that in today's dollars, that residual value, 4 years down the road, this is actually what it's worth today, $112,551, which works out nicely. All right, now let's do this. What's going to do the same thing in the present value. We've got the nominal dollar value. We've dealt with inflation. Now we need to see what this looks like when we figure in what it's the cost of the city borrowing this at 7% at a 7% discount rate, which is sort of not bad for a city rate. All right, so we're going to go equals. Now we want to know this number. Remember, everything over here is calculated from the preceding column. So it's this number, D19. We want to divide that, again, more than one way to do the math, by 1 plus the discount rate. And then we're going to raise that to the power of whatever the year is. In this case, it's year 2, which is in cell B19. All right, benefits for this one, same thing. Equals divided by 1 plus, where's my plus? The discount rate, close the brackets, raised to the power of whatever the year is. So multiply itself times 1, 2, and 3. That's the raising. So you could actually, You could actually set this up so it would be, some instead of raising the power, you could say that it would be, put everything in brackets and put, like in this case would be like B20 times all of this. So we'll say that it's raised to there. We shall rinse and repeat. Want to know what that 101,296 value is? So remember, at 4 years down the road, the when you take into the account of inflation, this has now gone up $101,000. 1 plus the rate at which the city is able to borrow the money, raised to the power of 4. All right. And now we do the same thing for the residual amount. Equals, whoops, that is not an equal sign. This amount divided by 1 plus the amount that the city can borrow, the rate that's what the city has to pay to for interest. Again, over 4 years. And you'll notice over here that apparently the spreadsheet thinks I've done this correctly. All right, here we go. Now, this is the other place that people, can kind of get messed up a little bit. If we do this like this, again, sometimes in here you'll see a problem. Whoops, better put that equal sign in there. It will not know what to do with it. If sometimes people add this up and the number will come up wrong here. Got to remember, you got to account for everything. Oh, whoops, subtotal. Left out the 9 switch. I have no idea why I keep doing that. All right. Therefore, what we want to know is if the total net present value is positive, it's a good deal. If this number is negative, it's a bad deal. Don't accept it under these conditions. So what you're going to do is you're going to rinse and repeat this for both of these. The second things, all you're doing is changing the discount rate and the interest rate. All right, and you're going to see if that number is over 0. If it is, then this is a good deal. All right, buy the trucks. You're on the plus side, $13,454 at the end of the day. It's a good decision. Buy the trucks. If this turned out to be a negative number, then it's not a good decision. You're not the savings and labor costs don't cancel out what it's going to cost you to borrow the money to buy the trucks. You understand? So you fill this out. Everything's true. The numbers are correct. This number is positive. Therefore, you would say, yes. Oops. Not booty. Buy the trucks because the net present value is positive. Now, it doesn't necessarily mean that you might not have you might have a political reason or some other reason, something else comes up that says, we're positive $13,000. But there may be another, you may have another reason for wanting to buy it or something or not buy it. But what you know is that you're actually going, at the end of the day, under these conditions, you're going to save a little money. Therefore, it's a good deal. You don't know under these conditions, well, we'll see. You'll do the calculations in this part of the spreadsheet. Is it positive? Is it negative? It just depends what your dollar margin is. As long as it's positive, it's a good deal. Okay. All right. All you have to do is replicate this in each of these two other sheets. All you're doing is changing the cell reference. You know, like the next one, you're going to be referring to these, and then to these, and then in this column, you're going to be referring to this instead of this. Just do this down here. Get your answers, plug them in, send me the spreadsheet. That is all there is to it. If you have a question, feel free to email me and I'll try to unstick you. But basically, you're just going to replicate this in two other spots.